In this lesson, we'll talk about how to initialize values within the array and some other processing of an array. So to initialize an array, other than through direct assignment through the keyboard, I can actually give it a list of values and preset them into the array. So here we've declared the array tests again, size 5, and I have given it an initialization list. And so in each of the locations, using curly braces as set notation, okay, I'm going to assign into those 5 locations the numbers 79, 82, 91, 77, and 84. The values are stored in the array in the order in which they appear in the list. And the initialization list cannot exceed the array size. It can be smaller than the array size, and we'll look at that in a moment, but it can't be any larger than the array size. So here we have of size 5, and we have 5 elements in our set notation. Arrays in C++ do not fill with default values. That happened in BASIC. It filled it with zeros for numerical arrays and with nulls for string arrays, but C++ does not do that unless we use a partial initialization list, and we'll see that shortly. Okay, and this includes string arrays. So if I would declare tests without an initialization list and I tried to access it, I would get garbage out of it. Some of those really large numbers, negative numbers, they would make no sense. Instead of getting the zeros that we would have gotten last year in BASIC. So here we can see they have declared the array called months or called days. They have given it size 12 and there are 12 numbers. Now they just wrapped it around. So here's an example. So rather than have it just string off in the line of code, they did wrap it around for ease of reading, but they filled in with the number of days each month would have. And so here it will see out month 1 has how many days, and so then it displays how many days there are in each month of the calendar using the initialization list. If I wanted to partially initialize a list, okay, fewer values than that which I am giving it size, I can do that. So here you can see we have declared the array numbers of size 7, but I only gave it a list of 4 values. And so what's going to happen is those 4 values will go into the first 4 locations. It's not going to skip any. It's not going to just kind of randomly fill in the 7. It will take them in order in the first 4 locations of the array. And this is the only time that it will give default values of zeros in the uninitialized parts of the array. Otherwise, it just fills it with garbage if I would not have given it a partial initialization list. So the list can be smaller than the size. It can't be larger than the size, but only when I give it a partial will it fill it with default values of 0. Now, implicit array sizing allows me to give it a declaration list without giving it size, but it will set the size based on how many elements are in the initialization list. So we can see that we've declared the array quizzes. I did not give it a size in the brackets, but I have 4 elements in my set. And so this one will be declared, quizzes will be declared with a size of 4 based on the initialization list given, since a size was not given in the square brackets. So there are a variety of ways that we can declare an array with values already in the array, and whether or not I would need to give it a size as part of its declaration. Processing array contents. So array elements can be treated as ordinary variables. We looked at some of those examples in the previous video lesson. We can use the incrementer and decrementer operators, and they behave a little differently depending on whether or not I have them inside of the square brackets versus outside. So we do not want to confuse that. So here we have them on the outside. And what it's going to do, it's going to add 1 to the value inside of the array. So let's say I have the array tests, and I have a 78, a 41, a 52, a 60. I'll just put a couple in there. And let's say at tests, I'm processing this array, and we're at element 2, which is this guy right here. And I put a plus plus out in the front. What it's going to do is it's going to take the 52, add 1 to it, and overwrite the location with a 53. So this then becomes 53 when it's on the outside. The decrementer would take 1 away. If I have it on the inside, it increments I, it increments the location. So instead, it is going to, let's say I'm at 2 is the value of I, and I have this plus plus on there. It's actually going to look at the array at 3. So it will look at the 60 instead, and it will not add 1 to it. Okay, all it's doing is referencing, okay, the element 1 away from whatever I is. All right, so there's a difference. This is incrementing I, where this is incrementing the value inside of the array. This is useful when I want to tally. Oftentimes, if I want to create a frequency analysis of something, being able to create a tally within a location in memory that corresponds, let's say with the alphabet, I can have each location correspond with a number or a letter in the alphabet. And as I pick off each letter of, let's say, a text, I can, tally how many A's there were, how many E's there were, and so on. Array assignment. To copy one array to another, we cannot do this direct assignment. If this is an array and this is an array, I can't just set them equal to each other. Okay, it won't work. It won't do anything for us. If I want to copy elements from one array into another array, then I must use the indexing for each array in order for me to do that. Okay, so it's imperative that you keep in mind that I must always reference an address within the array when I'm looking at each individual element of the array. Now, when I pass it as a parameter, the entire array, that's different because tests does equate to the entire structure as well as new tests does. But when I'm needing to deal with one element and another, and one location in another array, I have to do it a one-to-one in order to copy it over or to process it. I just can't tell it like we had seen in a previous slide to see out tests. That's illegal. Okay, I have to access each element of the array to display it. Printing the contents, again, using a loop, doing the same thing. I must look at each element of the array in order to display it to the console. If I want to compare elements in the array or compare two arrays, again, I must compare them element by element. So here I have two arrays, first array, second array, they're both of size 5. We have given them an initialization list. This is just testing to see if they're equal to each other. And so the only way for me to test as to whether or not they're equal to each other is to test each element of the array and checking one by one to see if there is a match all the way through. Of course, this one is going to return true because 5 is 5, 10 is 10, and so on in the array. But I had to process each element of the array in order to do this comparison to test for equality. I can't just test to see if, first array is equal to second array. That's invalid. I can't do that. It will not give me any valuable result. I have to test it one element at a time. Parallel arrays. So we discussed parallel arrays previously. That's the idea of where I have two arrays of different data types, but they share an association based on element. Okay, so parallel arrays are two or more arrays that contain related data. A subscript is used to relate the elements within the array. They may be, so it may be because they're of different types. So let's say I have an array called names. And so this is a list of students in a class. And maybe I have an array that is going to represent a score. Since these are numerical, they have to be stored separate from the names, but we use an indexing to share the association between the student and a score. And so everything related to Tom is going to be in index 0. Tom's in 0, so all of Tom's stuff is going to be in 0. So maybe I have a couple arrays. And so anything that belongs to Tom will be in that first index. Anything that belongs to Mary will be in that index 2. So we use parallel arrays when we have different data types, but we need to show a relationship between those different structures. So here's an example of parallel arrays. We have one of ID, it's of int type. We have one of average, which is of double type. And we have one that is a grade, which is a letter grade. And so here they're going to see out students' ID, their average, and then their grade. Maybe that's related to the average. So everything stored at index 0, again, would be related to, let's say Tom. Everything in index 2 is related to Mary. Here we see parallel arrays again, talking about number of employees. We have an array called hours, an array called pay rate. And so hours worked by employee 1. They're going to fill that in an hourly pay rate for employee 1. And then later we can process that through to create, some sort of payroll. But the idea that we're storing hours separate from pay rate. And then here they process it out in order to find gross pay. You can see they're multiplying the values from each of the arrays and then printing out their values. So they entered hours worked by 5 employees. They entered a 10, pay rate of $9.75, 15, and then 8.62, 20, 10, 50, and so on. And so then it printed out by multiplying the two elements together from the array. So using this idea of association by index in order to process elements of the array with shared data types.